Okay, let's jump right into the deep dive. This is where we take the sources you send us and really unpack the most fascinating ideas.
Mm-hmm.
And today, we've got something. Well, it's pretty wild. It's this idea that light,
Yeah.
the stuff we think of as just information or illumination, could actually become
Become
yeah,
something else.
substance. Yeah.
Become land, even.
It really challenges our basic intuition about light, doesn't it? We think of it as, well, as massless, intangible.
Right.
But this material you've shared dives into a really radical thought.
Right.
What if we could build and even live in environments literally constructed from photons?
Exactly. So that's our mission for this deep dive. Can we explore the absolute cutting edge of optical physics and material science that's in these pages?
And try to understand how light might actually form landscapes, structures, maybe entire worlds.
Let's dig in. Where do we even start with something like this?
Well, to even entertain building with light, you have to start with what light is, fundamentally. The sources lay it out clearly. A photon is a single packet of electromagnetic radiation. Okay, the basic unit, and then there's its famous split personality.
The wave-particle duality, yeah. It acts like both. And crucially, as you said, no rest mass.
But it does carry energy and momentum.
Definitely. And it zips along at the speed of light. See, always.
So it's not nothing.
Far from it. And that's where quantum field theory, which the material mentions, gives us a powerful perspective.
Mm-hmm.
It doesn't just see light passing through. It sees photons as excitations within the electromagnetic field itself.
Excitations, so like ripples or disturbances in something.
Kind of, yeah. It implies light is active, it's substantial in its own way. The source calls it something powerful, not just emptiness.
And we already know light isn't just passive, right? The sources bring up a great example, optical tweezers.
Ah, yes, a fantastic piece of physics. Arthur Ashkin's work got the Nobel for it in 2018.
So what do they do?
They use really tightly focused laser beams to physically grab onto microscopic things, tiny beads, cells, that sort of thing.
Like with light.
Yeah, trap them and move them around. It's using light to exert a real, tangible force, literally manipulating the physical world.
Okay. So the sources take that ability, light pushing, light holding, and they ask the big question, right?
Exactly. If light can manipulate matter, could it, maybe under just the right conditions, become matter, or at least act like it?
Could it become the substance of a place? The land itself?
And that question is the doorway. It leads us straight into the really fascinating materials and phenomena discussed in these sources. The things that seem to bridge that gap between light and, well, solid stuff.
This sounds like where the physics gets really creative.
Yeah.
Nanoscale stuff. The sources mention photonic crystals.
Right. Now, these aren't like quartz crystals you dig up. They're engineered structures.
Made by us.
Made by us. Often with these tiny repeating patterns on the scale of light's wavelength.
And what does that structure do to light?
It lets them control photons, really precisely. Kind of like how semiconductors control electrons in a computer chip.
So you can channel light.
You can channel it, bend it, reflect it, even trap it in place.
Wow. And the potential uses listed, things like creating tiny pathways for light signals, or surfaces that make weird mirages.
Or even logic gates for optical computers, using light instead of electricity. It's basically giving light a physical framework to navigate or be held within.
Okay, that's one piece. Then there's optomechanics.
Yeah, another fascinating area. This is all about how light interacts with physical movement, mechanical motion, but usually on incredibly small scales, nanoscale.
And what can you do when light interacts with motion like that?
Some pretty amazing things mentioned in the sources. You can use lasers to cool tiny objects down to almost absolute zero.
Cool them with light.
Yeah, by carefully managing the light pressure and interaction. You can also manipulate tiny vibrations or even create systems that keep moving or oscillating, just powered by photons. No other energy needed.
So light is directly making things move or stop moving.
Exactly. It's influencing the physical state, the motion, directly.
Okay, crystals guide light, optomechanics links light to motion. What else? There was something about condensates.
The photonic Bose-Einstein condensates.
Yes.
These are more experimental states of matter. Well, states of light, really.
Go on.
You manage to coax thousands of photons into acting together as one single coherent quantum wave instead of individual particles.
Thousands of photons acting as one entity.
And the really mind-bending part's what happens then. These photon groups start showing behaviors we normally associate with matter.
Like what?
The source mentions things like flowing like a fluid, or even holding a definite shape, almost like a surface.
Light holding a shape.
It's starting to acquire some of the bulk properties we expect from matter. It's a huge hint that light can behave collectively, materially.
Okay, I think I'm starting to see the toolkit. Photonic crystals for structure, optomechanics for force and motion. These BECs showing light can act like stuff?
Exactly. These aren't just lab curiosities. They represent uh, the fundamental concepts, the principles you'd need if you wanted to build a world not out of bricks and mortar.
But out of wave interference and light being trapped and optical coherence.
Precisely.
All right, so we have the concepts, these proto-materials. How do we actually build something? How do we go from lab bench ideas to, well, structures as the material envisions it?
Well, the sources point out we're already taking the first steps, experimentally. Holographic environments are one example.
Like Star Trek's holodeck.
Sort of, but maybe think smaller scale for now. Using lasers that cross each other to create actual 3D patterns of light in real time. The source calls it like digital clay.
Sculpting with light.
Yeah. And building on that idea of light pushing things, the optical tweezers idea scaled up.
Right.
Researchers like at MIT and Sussex they mention are making these levitation platforms using sound or light fields
The float things.
to float tiny particles in midair, yeah. And then they can arrange those suspended particles into complex shapes. 3D structures you can change instantly.
So you're building in midair, using light as your invisible hands.
Kind of like that, yeah. Using light as the scaffold and the crane, all in one.
Okay, that's labs. But the vision here is much bigger, isn't it? It draws on space exploration.
It does. Solar sails are the most basic example, already flying.
Using sunlight pressure, photon momentum to push a spacecraft, no fuel.
Right. So if photon momentum can push a whole sail across the solar system, what else could that pressure, that force, do on a grander scale?
And the possibilities listed get pretty ambitious.
They really do. Things like dedicated light highways through the vacuum of space, orbital habitats may be held together just by light pressure,
Floating structures bound by photons?
or even entire cities in zero-G may be shaped and maintained by complex, self-sustaining optical fields.
Wow. And metamaterials fit in here too, those weird things that bend light backwards.
Exactly. The sources see them as part of the toolkit. If you can design materials that control light in such unnatural ways, making things invisible, bending light the wrong way, then maybe you can use similar principles to sculpt the very terrain out of light fields.
Which leads to the ultimate vision in these sources.
Photonic megastructures, maybe vast cities orbiting stars.
Not built from metal mined from asteroids.
No, but shaped by incredibly complex webs of lasers, intricate patterns of controlled light.
Okay. The engineering is staggering to think about, but the sources push further, don't they? Into the experience, the philosophy of it all.
They really do. Beyond how you build it, what would it be like? What's the nature of a place made of light?
And the description is different. It's dynamic, always changing, massless, but powerful.
Impermanent, maybe, yet structured. How does that feel?
What does it mean to live there? To exist inside a reality made of photons. It feels utterly alien compared to, walking on solid ground.
And yet, maybe not completely alien, we're already getting hints with things like VR and AR, right?
Virtual and augmented reality. Yeah.
We're already creating and interacting with environments made purely of digital light, merging our senses with these intangible illuminations.
And the material suggests future photonic architecture could be even more integrated, maybe responsive.
Yeah, like imagine spaces that could reconfigure themselves based on your thoughts, your neural signals maybe, changing the layout to match your mood or what you need to do.
That's a lot. Which leads to that really fundamental idea I mentioned.
Does physical matter even become necessary in such a world?
Could the illusion of space, perfectly rendered and maintained by light fields, be enough?
Enough to live in, to experience reality within.
And the shift that implies, moving from inhabiting matter
to inhabiting meaning. Inhabiting structure and form that's sculpted purely from light itself.
It's a profound thought. But the sources are careful. They bring up the tough questions, too. The practicalities, the ethics.
Absolutely. If your whole environment is made of light, who controls that light?
Right. Who owns the light switch for your house?
Yeah.
Or your city?
And could that infrastructure be hacked? Could someone just turn off the floor? Or collapse the walls?
That's terrifying.
And the bigger question they pose, is a world made of photons ultimately more freeing because it's so adaptable, maybe infinite? Or is it more fragile?
Dependent on maintaining these incredibly complex, delicate energy fields. One power outage and poof.
These are huge questions that trail behind the amazing possibilities.
It really is a lot to process. We've gone from the basic nature of a photon through these potential building blocks,
Photonic crystals, optomechanics,
BECs.
to methods like light scaffolding and holographic shaping, all the way to megastructures and these deep questions about reality itself.
And the key takeaway from the sources seems to be, this isn't just hand-wavy sci-fi. It's grounded in real emerging physics and engineering,
Stuff happening in labs now, pushing boundaries.
pushing what we thought was possible based on our understanding of light and matter.
And it definitely leaves us and you listening with that really provocative final thought from the material, that maybe the next big step for humanity isn't just using light better.
But actually becoming part of it, inhabiting these architectures of pure illumination, surfing the light fantastic, almost literally.
The idea that one day light might not just show you the way.
It might be the way.
Dazzling thought.
Absolutely.
Yeah.
Definitely gives you something to mull over. We hope you keep exploring these concepts.